Alright, in this video I'm going to teach how to graph quadratic equations on an xy plane. Okay, to graph the quadratic equation we need to know these rules, or you can call them steps. We will obey these steps and form an equation accordingly. Okay, let's have our first example. We have y equals to x squared plus x minus 30. Okay, that's our equation. Okay, now when we start off, let's see the first rule. It is finding the type of curve. There are two types of curve, or the upward facing or the downward facing. You can call it a smiley face or a sad face. It's up to you, whatever you call it. We'll just use the upward facing or downward facing. Okay, the upward facing is a curve which has the x squared coefficient as a positive number, as something positive, positive 1 or anything positive. This type of curve has the coefficient of x squared as negative 1 or any negative number. Okay, that's the first rule. Okay, here we can see that our x squared coefficient is positive, so our curve is this shaped. Our curve is like this. Okay, next step is finding the y-intercept. Y-intercept is a point in the curve point on the graph where our curve intersects the y-axis. This point. I just draw this curve. Okay, or if a curve is like this point. That's the y-intercept. Y-intercept we can find by putting our x equals to 0. Whenever we put our x equal to 0, we are left with this constant term. Okay, whatever our constant term is, that is our y-intercept. This last term, this c is our y-intercept. Okay, now we know our c is minus 30. That's y-intercept. Okay, now we know our y-intercept. Let's move on to a third step. Our third step is finding the number of roots. A quadratic curve can be of three types. Either it can intersect the x-axis as 2 points, or intersect the x-axis at only 1 point, just touch it and go up, or entirely lie above the x-axis. We can know it by the b square minus 4ac formula. If this b square minus 4ac is greater than 0, we will have two distinct real roots. The curve will be like this. That will be our curve type in that case. If b squared minus 4ac is equal to 0, our curve will be this, of this type. It will just touch the x-axis and go back up again. What if our b squared minus 4ac is less than 0? Our curve will be like this. It won't touch the x-axis anywhere. Same goes for the graphs like this. If they intersect the x-axis at 2 points, it has the b square minus 4ac greater than 0. If it intersects at 1 point, it's equal to 0, or if it does not intersect, it's less than 0. Okay, so that's our third rule. It will tell us how many roots does our graph has. We need to know it while graphing our quadratic equation. Okay, so here what is our b square minus 4ac? Our b squared is positive x squared, it's 2, minus 4 times, what is our a? A is 1, the x squared coefficient is 1, and our c is minus 30. Okay, so 2 minus 4 times minus 30 is positive 120, or we get 122. That's a highly positive number, so we know that we have two distinct real roots. Our curve is somewhat like this. It intersects the x-axis at 2 points. Okay, we know three things for now. Our graph y-intercept is way below. It's like minus 30. The y-intercept is very below, like somewhere over here. It can be like this. Our graph can be like this. It's intersecting like over here and here. It can be anyway, but we know at minus 30 is our y-intercept. Our graph intersects at 2 points, and our graph is upward facing. That's all we know for now. Okay, now let's go further and Our fourth step is finding the roots, finding those 2 points where the graph intersects the x-axis. That we can do it by 3 ways. Number 1 is factoring, number 2 is using the quadratic formula, or number 3 is by completing the square. Completing the square is least recommended because it's very complicated and lengthy, so there are chances you'll end up making mistakes. So what we prefer is the factoring method. That's simple and that's quick. Okay, so here we have x and our x over here, and we just take the LCM of this 30. That you have 2 times 15, 3 times 5, and 5 times 1. You have 2 times 3 is 6, and 5. We have a two numbers, and we need to add them somehow to get a positive x, so we should have our 5 negative. 6 minus 5 is 1, so here we have a positive 1, and when we multiply 6 and minus 5 we get minus 30. So these should be our 2 numbers. It's minus 5 and plus 6 equal to 0. To find our roots we need to keep it equal to 0, and we need to keep it equal to 0 because when the graph intersects the x-axis, or y is equal to 0. On this line it's 1 and this point is 0, so we keep y equal to 0. So when it's equal to 0 we keep it x minus 5 equals to 0 and x plus 6 equal to 0, and what we get is x equal to 5 and x equal to minus 6. These are our 2 roots. We have u minus 30, and 2 roots are 5 and minus 6. Okay, now we know our roots. If you don't know how to solve a quadratic equation and find the roots, I have videos on all 3 ways: factoring, the quadratic formula, and completing the square. You can check their links in the description of this video below. Okay, let's move on to our next step, which is 5th, finding the turning point of a curve. It's an important step and kind of difficult if our b square minus 4ac is less than 0. Okay, since we have a b square minus 4ac greater than 0, so it's an easy question for now. In the next video I'll cover the difficult part of this. Okay, so here we have a turning point, which is where does a graph turn? When we have a graph, when it turns, it's also called a vertex, or this way, this is our turning point of our graph. So how do we find it? A simple way is to find the midpoint of our roots 5 and minus 6. Find the midpoint of them, that's our x-intercept, and put that x over here to find our y. Or the other way is to, well, that's the same way. We just use the sum of 2 roots formula and divide it by 2. The sum of root is minus b upon a, and when we have the sum of 2 roots we just divide it by 2. Like our root is 3 and 5. Our sum root is 8, and when we divide it by 2 we get 4. 4 is between 3 and 5, so our graph should be like this. Here's 4. Okay, so let's do that with that. What's our sum of roots? Our sum of root is minus b upon a. Minus b upon a is the formula to find the sum of roots. I have a video on this too. You can find its link in the description below. Okay, when we have minus b upon a, or minus b is minus 1 because our coefficient of x is 1 and our a is also 1. Okay, so our sum of roots is minus 1. So we need to divide it by 2 to get our sum of roots divided by 2. That's minus 0.5. Minus 0.5 is our x coordinate of our turning point. We need to find a y coordinate. To find the y coordinate we need to put this 0.5 in this equation, and let's put it to find y equals to, what I'll do is minus 1 upon 2 whole squared minus 1 upon 2, it's minus 1 upon 2 minus 30, and we get y equals to 1 upon 4 minus 1 upon 2 and minus 30. Okay, we take a 4 as a common denominator, and we have 4 over here, and 1 minus we multiply 1 with 2, and then we get 2 and minus, no, 30 will be multiplied with 4. We have minus 120. 30 will be multiplied by 4. So yeah, we have minus 120. So what we have is 121 divided by 4. That's somewhat, it's minus 121 divided by 4. That's somewhat near 30.25. Yeah, that's somewhat 30.25. Okay, now we have our turning point as well. Our turning point is minus 0.5 comma 30.25. That's a turning point, and the last step is to join all the points to form a curve. Okay, so now let's draw our x and y axis to graph it. Okay, since we know that our coordinates are 5 and minus 6, so we'll have to include both of them. I'll draw mostly below it because our intercept is minus 30, so it should be somewhere over here. Minus 30. Our graph is cutting over here. I'll just plot the important points we have. Our y-intercept is minus 30. Our x-intercept is somewhere over here. That's minus 6, and that's positive 5. That's what we have. And one more thing we have is our minus 0.5 is somewhat close over here, and minus 30.05 is, that's minus 30.05. I made a mistake. Minus 30.05 is somewhat over here. So yeah, that's where our graph turns, and we know our graph is U-shaped, so our graph is somewhat look like, I'm not very good at drawing. I'll just try to be as accurate as possible. That's where our graph turns, and that's minus 30 is from where our graph cuts this y-axis, and it goes up and crosses this 5 and goes on and on and on. That's x-axis, that's y-axis, that's axis. Okay, so that's how we graph this equation, quadratic equation, by following all these rules. You need to memorize these rules to find these. If you don't even memorize, you will need to find these certain points to connect and form a curve. In the next video, I'll graph difficult and more complex quadratic equation on an xy plane, and I'll upload their links in the description below, so do check them out, and it will help you have a grip on graphing the quadratic equations. That's it for now. I'll see you next time.